In this video, we are going to study about some general characteristics of the group 15 elements, especially that of nitrogen, and some compounds of group 15 elements. Now, nitrogen, the very first member of group 15, shows anomalous behavior as compared to the other members of the group. And the reason behind this anomalous behavior lies in some of its properties. The first of all, it being its small size. Nitrogen, being the very first member of the group, has only 2 shells in its atom, in its electronic configuration, and hence due to this it shows properties different from the other members of the group. The second reason being its high ionization enthalpy, which is again related to its small size. The third being absence of d orbitals. Since it has only 2 shells, d orbitals are absent in the case of nitrogen, which is present in the case of all other members of the group. Then the fourth property being its very high electronegativity as compared to other members of the group. And the fifth one is its ability to form pi bonds, p-pi type of multiple bonds by effective overlapping of the 2p orbitals. Now, why nitrogen exists as a diatomic molecule, whereas phosphorus, the very next member after nitrogen in the group, is tetraatomic in nature? Now, this property can be explained by considering its ability to form stable p-pi type of pi bonds due to effective overlap of the small size 2p orbitals, which is not possible in the case of phosphorus. Then secondly, why nitrogen lacks catenation tendency, which is seen in phosphorus? Now, this is because of the weak N single bond N bond strength, and this can be explained on the basis of its small size. Due to its small size, the electron density of the two atoms are closer to each other, and hence there are very high inter-electronic repulsions operating between the two atoms. This leads to weak bond strength, and hence it lacks the tendency of catenation. Then why nitrogen can have a maximum covalency of 4 only? Why it cannot show a covalency beyond 4? So the reason is due to the absence of d orbitals. It has only 4 orbitals in its valence shell, that is the second shell, one being the 2s orbital and the other 3 being the 2p orbitals. So a total of 4 orbitals can contribute towards formation of 4 covalent bonds at the maximum. Hence it can show a maximum covalency of 4 only. Now, coming on to some of the important compounds formed by group 15 elements. The first type of compounds being formed by them is the hydrides. Hydrides are the compounds of elements with hydrogen, and in case of group 15 elements, the general formula of the hydrides formed by this group of elements is EH3, where E represents the element. So, for example, if we write the formula for the hydride of nitrogen, it comes out to be NH3, known as ammonia. For phosphorus, the formula is PH3, known as phosphine. For arsenic, it is ASH3, known as arsine. For antimony, it is SbH3, known as stibine, and for bismuth, it is BiH3, known as bismuthine. And all these hydrides of group 15 elements are gaseous at room temperature. Now, coming on to some of their general properties. The very first property that we can discuss here is their stability, thermal stability, that is how stable they are towards thermal decomposition. A stability of a compound depends upon the bond strength present between the various atoms bonded to each other. So in hydride, The bonds are between the element and the hydrogen atoms. Strength of this bond decides the stability of these compounds, and the strength of this bond depends upon the size of the element. So since the size of the group 15 elements increases down the group, the strength of the bond, which is formed by overlapping of the orbitals of the two atoms, that is hydrogen and the other element, that goes on decreasing. And since the bond strength decreases, thermal stability decreases down the group. Next property that we need to discuss is reducing power of the hydrides. Reducing power of these hydrides depends upon their ability to produce hydrogen as a result of breaking up or decomposition of the compound, that is breaking up of the EH bonds. So since the EH bond become less and less stable as we are moving down the group, the release of hydrogen becomes easier from ammonia towards bismuthene, and hence the reducing power of the hydrides increases down the group from ammonia to phosphine to arsine to stibine and to bismuthene. So stability of the hydride decides the reducing power. Less stable is the hydride, more is the reducing power of that hydride. The third property that we need to discuss about the hydride is their Lewis base character. Now Lewis base is that substance which has a tendency to donate its lone pair of electrons. Now, each of the hydrides of group 15 element has 3 bond pairs and 1 lone pair, but the tendency to donate this lone pair decreases down the group. This could be explained by considering the electron density that is present around the central element in each of these hydrides. As the size goes on increasing, the electron density goes on decreasing, and with decrease in electron density down the group from ammonia to bismuthene, the tendency to donate lone pair of electron decreases, and hence the Lewis base character also decreases from ammonia to bismuthene. Next we can talk about their boiling points, which is one of the physical properties of these elements. Now boiling point increases when we move from phosphine to bismuthene. Now this is because boiling point depends upon the strength of the intermolecular forces. Since they are all covalent molecules, so the nature of the bond which holds these molecules together in their gaseous state is weak van der Waals forces, and van der Waals forces depend upon the size or the molecular mass of the molecules. Greater is the size or higher is the molecular mass, stronger are the van der Waals forces. So since from phosphine to bismuthene size is increasing, molecular mass is also increasing, hence the strength of van der Waals forces increases, therefore boiling point increases. But if we see the boiling point of ammonia, then we find that boiling point of ammonia is higher as compared to that of phosphine, as well as it is higher as compared to arsine. Now the reason why ammonia shows a higher boiling point than phosphine and arsine is because nitrogen is an electronegative element bonded to hydrogen, and hence it can form intermolecular hydrogen bonds. So the molecules in ammonia are held by intermolecular hydrogen bonding, which are stronger in nature as compared to the van der Waals forces. Hence the boiling point of ammonia is greater than phosphine as well as arsine. Then we have bond angle of the HEH bond. HEH means E stands for the central element, which can be any of the group 15 elements, and both H stand for the hydrogen atoms. So if we see the bond angles of all these hydrides, then we'll find that the bond angle decreases from ammonia to phosphine to arsine to stibine. For ammonia it is 107.8. For phosphine it is lower than 107.8 to about 96 degrees, and then it further decreases down from phosphine to arsine and styrene. So this decrease in bond angle is because of the size of the central element. As the size increases, the lone pair bond pair repulsions which are operating in these molecules, the strength of these repulsive forces also goes on changing. In the case of ammonia, the lone pair bond pair repulsion has to compete with the bond pair repulsions which are also prominent, and hence it does not so much dominate over the bond pair repulsions as it does in the case of the remaining compounds, that is phosphine, arsine and styrene, where due to increase in size the bond pair repulsions become less and the lone pair repulsions start dominating over the bond pair repulsions, and thus when we are moving from ammonia to styrene, the bond angle goes on decreasing. These are some assignments for you based upon today's discussion. What is catenation? What is covalency? How is a pi bond formed? Why nitrogen does not form NCl5, that is nitrogen pentachloride? Why nitrogen is a gas but phosphorus a solid at room temperature? Why nitrogen shows a maximum covalency of 4? And of course, arrange the following in increasing order of boiling point, that is ammonia, phosphine, arsine, styrene and bismuthine.